Capstone project is intended to teach us to the real life situation, so how to be out there, how to get a project, how to deal with companies, how the back and forth emailing works with them, how to get their attention, what it's like, what you have to provide them with.
I think the capstone is intended to teach you how to work with your teammates. The capstone is more of the process of getting to your destination, and it's a learning experience for sure.
It's supposed to give us an idea of what the real world is going to be like industry-wise. So we're given these projects that relate to real-life situations that we're going to face out in the workforce.
A group of SAIT students contacted Autopro to see if they would be interested in sponsoring a capstone project. Project managers Don Keekley and James Kudo offered to create a project for the students and mentor them through the entire process.
I got interested with the Capstone project because of my previous relationship with SAIT, and I like to help students. And so Autopro became involved in this project to come up with an automation problem for the students to solve.
We weren't expecting to have a client company in the first place. It was actually hard talking to a few of these companies because the furthest we'd get to is the human resources, and they just close the phone. They weren't really interested in projects, but we were lucky enough to come across Autopro and get this project.
The Capstone project we're doing is an automated system that dictates and monitors flow.
Autopro asked us to automate a system with a control loop where we can control level and potentially control temperature as well.
Our project was to eliminate the need for a person to be on site, to be monitoring for flow. So we try to make the process automated, so it'll be all displayed on an HMI screen, and there'll be no need for a personnel to be on there and monitoring at all times for the flow being proper and safe.
Based on the equipment, we were able to come up with a very simple process, which is basically a tank level control and flow control that they're going to do, and they're actually building up the equipment to simulate it with water. However, the actual project that they're developing for us is meant to be real world. So instead of water, for example, we're using condensate as a medium. We're having the students actually specify equipment that they would put in the field if it was an actual field installation. We're having them go through the engineering process as though we were their customer and they were our engineering firm, just to give them some real world practical experience.
Well, our project scope of work changed numerous times, but what we have now is the system, so it's filling up a vessel full of fluid, and what our system is supposed to do is, if the valves are changed manually in any sort of way, the flow and the level will maintain the same. So if the flow is reduced, our valve will open up and allow more fluid to pass through.
And we're giving them the whole project experience with change and information coming in late and deadlines, and so we really want to try to give them a real life project experience as close as we can possibly do given the situation. And I think the kids have been really enjoying it, and hope they're learning a lot.
What Don and James were with as in our project, they were clients. So we were trying to do a real world project. So as clients, they provided us a scope of work, so something that they wanted to be done, and we had to meet the criteria for their scope of work.
Well, Don and James were really helpful. We did P&ID drawings for them, and they would give us the feedback we needed on how to improve on that and what it would be to have it on standard, up to standard.
We ended up being limited to some of our equipment, so we even had to put them through some scope changes, which is very usual for projects. So they got to know about the change of management process and writing control narratives and drawings and P&IDs and that kind of thing.
Unexpected challenges didn't faze this group of determined students. When they were unable to procure a flow sensor for their system, they simply designed and 3D printed their own functioning sensor.
The one thing that we've designed for our project is the flow sensor. In this little glass tubing, there's a turbine which will rotate as the water flows through. And as the water flows through, the magnets that are in there will rotate as well. And outside the glass tubing will be a magnetic reed, which will give out the signal true to false.
At the end of the semester, industry sponsors and supporters were invited to SAIT's annual School of Manufacturing and Automation Showcase, where all the students had their capstone projects on display.
How the systems operates is right here you have a pump in a reservoir tank and piping attached to a pneumatic actuator. The pneumatic actuator has a diaphragm that can control the flow, and the flow is controlled by the PLC. So when the water is running through our pneumatic actuator, this runs as a backup to make sure that the flow rate is correct. And this is a flow meter that we 3D printed and added magnets to. So the flow rate will come through here into this column and it will fill, and it's maintaining a steady flow all the time. So if we shut this valve, we've installed a high limit here, and this will shut off the pump and disengage our controls as soon as it reaches our sensor. So this is our controlling our pump. So the pump is connected to a relay, and you can see it's a 1, so that means it's on. This is our high-speed counter for the flow meter, the blue guy with the magnet spinning. And this is giving us a calculation, so it's pulsing. You can see at a steady rate, it's consistent. This is our control for the pneumatic actuator. You can see it's at 32,000, so that means it's fully open. If we set it to 0, it'll close half the way. If we set it to minus 32,000, it cuts it off. So you can actually control the pressure with the pneumatic actuator in the system right from here in real time. So if there's an emergency, you can just shut it off.
Under the short time frame that we had to get this project done really fast, and in order to do that we had to work together as a team, and we did get down on each other a little bit, but that was only for a short time, and it's a good thing that we are all friends and we're in the same program, so we got that done fast.
I think in reality, that's what it would actually be, because in industry, there's so many variables that can happen, and just like James, our sponsor, said, there's always something that's needed to be changed, but the deadline will always be the same. So I think that's a good experience for what we're gonna expect in the real world.
It got me to see how it is to work as a team on a project, and how to face problems, how to get move forward after being in a situation where you don't know what to do, what your next step will be. It's always problem solving was a really great experience, learning how to problem solve. And it put us in a really nice position to learn what it's going to be like to be on deadlines and not having the stuff on time, but recently to provide the project on time.
It was stressful at times, but also very rewarding.